Welcome csc121 class to ex5RunningPace. We worked on this in class, and if you didn't get a chance to work on it, here's a quick little overview. Here's the finished product, and this is set up based on if you run, you want to figure out how fast you're running by your pace, which is basically your minutes and seconds per mile. And that's how you figure out whenever you run, you know your minutes and seconds, and if you want to know your pace, you want to know your minutes and seconds per mile. We're not doing miles per hour, we're doing minutes and seconds per mile to figure out how fast you're running. So anyway, if I put in a run, and these are actual run times here, so I'll put in 25 for my minutes and 23 for my seconds, and then I usually run 3.1 miles, which is a 5K, so I'll put in 3.1. And that's an accurate time because there's apps that do this, but I wanted to use this as kind of a learning exercise. But I know that's accurate, 8:11 for 3.1 miles. So that's the way it should come out. And even if you put in something, even if I run this again and put in something like 15, this should come out to 8:09. It should, even though it's just 9 seconds, we need to put a leading zero in front of that. So that's a little thing we'll have to do at the end, a little bit of formatting we'll put in our string at the end. So this is the finished product, and I'm going to go here to one I already have started. There's no reason to kind of start this from scratch because you know how to do some of this stuff. I'll just go here and I'll name it, and I'll name it ex5RunningPace, and I'll give it a V since I'm recording a video. And there's my ex5RunningPace, and I already have this started, and I have it divided up: inputs, calcs, and output. And I have my output commented out right now because I'm going to get an error because there's variables used in here that I don't have yet. But the idea of this would be just have an input for your minutes and have an input for your seconds, and then for miles you also want an input for your miles because we have to put in 3.1 or how far you run. Now the first two are ints because we want those ints. We don't want any decimal for minutes. We don't want any decimal for seconds. If you ran 25 seconds, we don't need 25.2 seconds. That's not going to make a big difference on your run. So those could be integers. Those could be single numbers without any decimals. But for miles, since you might run 3.1 miles, which I do, that's a decimal, so we'll put that as a float. Those are our inputs, so that's set up pretty standard. You know how to do that. And then here's our calculations. And if you think about it, since we're using two separate values, I have one here called MPM, which would be minutes per mile, and it would just be minutes divided by miles. I have one called SPM, which would just be seconds per mile, and you would just say seconds divided by miles. And what you should be able to do is go down here and do something like put MPM down here and then put something like SPM, and we should be all done. And that's all you should really need. That should be pretty easy. But obviously if it was that easy, I wouldn't have made it an exercise. But let's just see what happens if we just take that idea and do that and run it. So I'm going to run it here because that's actually the idea, and I'll put in the same times, 25, 23, and I'll put in 3.1. And what you get are these decimals here. And for the minutes, I'm getting 8.06, and for the seconds, I'm getting 7.4 whatever. And that's actually accurate, except it doesn't look good, and it doesn't really tell us minutes and seconds because there's minutes with a fraction here. The problem is because miles is 3.1, it creates this into a float, and it gives us minutes as a decimal term. And you can't just round it off because these are seconds that matter. If it's 8.06, you can't just cut it off because you'll make your time too short. So we have to take whatever's down here and add that on to the seconds here. And then we have to round it all off. So there's some conversions we have to do here. And there's different ways to do it. Students suggested converting it all to seconds. And you can do that. I did that. It didn't save me any lines of code. And I don't know, I think it made it more confusing for me. But that's just me. So you could do it any way that makes more sense. I'm going to start from this point and just kind of do variations on this because this made sense to me. So whatever makes sense to you, if you want to do total seconds and convert everything to seconds and then do a conversion later, you can do that. But this is actually accurate, so this is working. What we have to do, and my idea was to chop this off and add it to that, and then make sure, but before you add it, make sure you convert this to seconds because this is not seconds. This is a fraction of a minute, 0.06 of minutes, which would be whatever, you'd have to times 60 to get the second. So I'm going to kind of take it from that standpoint, and these might have to change because I might have some other variables here. So seconds per SPM equals seconds per mile, that's fine, except you can see what's happening here we have 7.4, and what we can do here is probably just round it up or round it down. So I'm going to put round on here, and if we just use the built-in round function, it's just going to round it up or down. So 7.4 would get rounded down to 7. It would not round it up. And again, this is a fraction of a second, so it's not a big deal of doing that. Now, what we're going to do here, or what I did, was for this value that we get here, which is like 8.06, I'm going to actually take NPM, and I'm going to have a version, and I think I called it round, or maybe I'll call it round because that makes more sense as far as what we're doing, even though we're not going to round it. I'm going to call one called NPM round. That means it's just going to be single minutes. And that's from the value that I'm getting here. So it's the 8.06 that we're getting initially. And then what I'm going to do is I'm just going to convert it into an int. Now, you might say, well, why not round it? Well, we're not going to round it. What I'm actually going to do is I'm going to just cut off. I want to cut off that 0.06. I don't want to round it down. I want to cut it off. So I'm just going to put NPM in here. So I'm taking the value that I got, the 8.06, and I'm making it into an integer. Now, we still have, because I'm making this a new variable that's rounded, I still have this old variable, which is the 8.06, or which is the version with the decimal. But I still have that extra. And what I want to do is actually subtract this one from this one. So this is this currently, and I'm just putting this here, and I'll get rid of it. This currently, based on the value I have, is 8.06. So I want to subtract this from this, but we're going to, and so I can have this and then convert it into seconds and add it on to that. So that's kind of what I want to do. So either way, I found it a little confusing, but that's what I want to do here. So what I'm going to do next is I'm going to create a variable, and I'm just going to call it npm, and I'm going to call it xsecs, because either the extra seconds is what I'm going to figure out here. So I'm going to get the extra seconds. So the difference of these is what I'm going to do here. So it's the extra seconds. So it's this 0.06 part that I'm actually looking to get here. That's why I'm calling npm xsecs. And what I would actually do is just subtract. I would do npm minus, and I'll put a space here, and I would subtract npm round, or RND as I have it. So what I should get is that 0.06, and then when I get that, and I'll put it in parentheses because if I combine these, what I do when I get that, I'm just going to get 0.06, but that's not seconds. To make it seconds, I have to multiply it by 60. That will convert it to seconds. So I'm kind of doing two things here. I'm getting the difference, and then I'm multiplying it by 60 to get those extra seconds. And then those extra seconds can be added on to here. So I could really do this. I could really, stick this in here and plus npm xsecs. That should work. So then I'm really adding them here. I'm getting my value of seconds per miles, which is this. I'm adding those on, and then I'm rounding the whole thing down. I already had a round in here to kind of round it down. So let's see how that works. Again, instead of, it would be nice if this was just a single number, we'd be fine, but it's not. So we have to take that little extra, which we're doing this thing to get the extra seconds, and then multiplying it by 60. Because remember, this isn't seconds, it's 0.06, a fraction of a minute. What we're going to do here is, I guess, see if it works. Now let's check out our variables here, because I'm still using, I still have SPM here, and I'm still going to use NPM. Actually, I'm not going to use NPM, because remember, NPM is the 8.06 one. So I'm just going to use the NPM round in here, because that'll give me the single number. And again, you could put comments here so you remember what you're doing. So you're figuring out the extra seconds, above the minutes. That's what that's doing. But hopefully xsecs kind of makes that clear. So let me run this, and I'll try it out. And I'll do 3.1, and that works. So that's all I need to know is it works. So it's correct. Now the one thing I also want to check is, I'll run it one more time. If I do 25, I'll make it 15, and I'll still do 3.1. And there it says your pace was 8.9. Now that is 8 minutes 9 seconds, which is actually accurate, except it's 8.9, and we use, anything under 10, we're going to see it as 09. So that's not really an accurate view. So in our string over here, we can actually put in something with a colon and a 02, which is going to put a leading 0 if it's necessary. So if we don't need a leading 0, it won't do that, but it'll make sure that it keeps it 2 characters and puts a 0 in front of it. It's going to make sure that it formats it to 2 decimals, and then also make sure if it's under that, it'll put a leading 0 in that. So let's see if that works. Again, I'll do 25, and this time I'll do 15, because 15 will make sure it's under, the pace is like 8:09, and it's still 3.1, and there it is. That works, and that looks good. So that's it. That's all you have to do. There's, again, a couple little calculations you have to do. If you want to try it by doing total seconds and working it out that way, if you like kind of working through that math, you could try that, but that's the way, this is the way that kind of made sense to me, is just getting that little extra seconds from this 8.06 and then making sure I convert it by doing times 60, convert it into seconds because it's a fraction of minutes. 0.06 is minutes. When you multiply it by 60, then it's actually seconds, and then make sure you add it on. This is adding on that little extra onto what we initially have, and because by order of operations it's figuring out this first and then adding it. Otherwise we'd have to put another parentheses in here to kind of force that to go first, and we're rounding the whole thing off. We're rounding off our seconds, which we can do. We could round second. We don't need decimals on seconds, so that's what that's doing. So, and then this put the leading zero in there, so everything worked out okay. And 4 lines of code for calculations, that wasn't too bad. So that's EX5 running pace.